numbers are 4, 9, 16, 25. I did 2 squared, 3 squared, 4 squared, all the way up to 10 squared, 11 squared, 12 squared. After that, it gets a little bit too large for us to have to memorize. But you should be familiar with what makes something a perfect square number, and you should be familiar with what makes a variable a perfect square term. What is it that these all have in common that makes them a perfect square term? Madeline? What do these all have in common? Why are they all perfect squares? Because their exponents are evens, aka they're multiples of 2, right? So they have square roots. This one's square root is x to the 5th. This one's square root is x to the 4th. This one's square root is x to the 3rd, and so on. Okay? Perfect squares. Perfect cubes, the lists are a little bit shorter, because obviously if you're multiplying something by itself 3 times, they get bigger quicker. So 8 is 2 times 2 times 2, so the cubed root of that is 2. 27 is 3 times 3 times 3, so the cubed root of that is 3. 64 is 4 times 4 times 4, so it has a cubed root of 4. And this is 5 times 5 times 5, so the cubed root of that is 5. Okay? After that, 6 times 6 times 6, it's getting a little large, so you're not expected to be as familiar with those. What makes all of these perfect cubes? All of their exponents are what? Multiples of 3. So they all have cube roots. For example, x to the 12th is the same thing as x to the 4th times x to the 4th times x to the 4th. So the cubed root of that is x to the 4th. What's the cubed root of this? X to the 3rd. What's the cubed root of this? X to the 2nd, and the cubed root of this is x. Essentially, you can just divide each of those by 3, and you'll get the new exponent for the cubed root. 4th powers, the list gets even shorter. As far as numbers are concerned, this is 2 to the 4th power, so 16 has a 4th root of 2. This is 3 times 3 times 3 times 3, so the 4th root of 81 is 3. After that, it just gets too big. 4th powers have exponents that are multiples of 4, right? So this has a 4th root of x to the 3rd, because x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd gives us x to the 12th. Do we follow? And then 5th powers, really we only have 2 to the 5th power, so this has a 5th root of 2. This has a 5th root of x. This has a 5th root of x squared. This has a 5th root of x cubed. All of those are multiples of 5. Okay, so getting familiar with these patterns. Now, how do we simplify? Do you remember what you did in Algebra 1? Starting with a square root, how you reduce that? Anyone? Anyone at all? Okay. If you're looking to break down a square root, you need to find the biggest perfect square that goes into 27. So if I look at my perfect squares list, the biggest number that goes into 27 evenly is 9. So I'm going to break down the square root of 27 into the square root of 9 times the square root of 3. And then we have the negative out in front. And the reason I chose 9, the reason I choose a perfect square, is because now I can actually apply that square root symbol. Jake, what is the square root of 9? 3. So it just becomes a whole number, and your simplified version is negative 3 root 3. Good? 242, again, it's still the square root. So what's the biggest perfect square from our list that goes into 242? 121. So I'm going to keep the 9. I'm going to break up root 242 into root 121 times root 2. And the square root of 121 is what? 11. So the 9 that was already out there, So 9 times 11 is 99. So we get 99 root 2. If it's a cubed root, we look for the biggest perfect cube that goes into the number. 54, if I look at my perfect cubes list, 27 goes in. So I'm going to split this up into the cubed root of negative 27. Keep your negative sign with the number that we know the cubed root of. 27 times what gives me 54? 2. So I broke up negative 54 into negative 27 times 2. Because what is the cubed root of negative 27? Negative 3, right? Negative 3 times negative 3 is 9, times another negative 3 would give us to negative 27. So that's negative 3, and then just times the cubed root of 2. And that's your final answer. The fifth root, we don't really have many options, so God help us, hopefully 32 goes into 243. So you should have your calculators handy to see how many times, so we know how to break that down. 243 divided by 32. Ooh, it doesn't go in. What else? So 32, what is 3 times 3 times 3 times 3 times 3? Oh, 243. Let's add that to our list. So that does have a fifth root. Does anybody know how to check on your calculator to see if a number has a fifth root? If you go to math, there's the cubed root option or there's the x root option. But you actually have to type in the 5 first. So if I go back to my home screen, if I want the fifth root, I type in 5, I hit my math key, and if I go down to this x root option, that'll make that, it'll turn that 5 that I had typed in into the fifth root of 243, and that is a perfect fifth power. So this whole thing is just 3. And then I have a negative 2 out in front, so negative 2 times 3 just makes that a whole number, negative 6. And there's no root left over. Does that make sense? Okie doke. Now, same idea, we just get into having variables involved. So when you're taking the square root of 32, we're going to do the same thing. We're going to split that up into root 16, because I know 16 is the biggest perfect square that goes into it, root 2. Now, is x to the 7th something I can take the square root of? No, because it's not divisible by 2. But what's the first number underneath 7 that's divisible by 2? 6. So I'm going to break this up into x to the 6th times x to the 1st, technically, right? I'm using a little bit of exponent rules there. I'm replacing x to the 7th with x to the 6th times x to the 1st. So I usually like to then circle those items that I know the square root of, because I'm going to apply the square root symbol to those. So the square root of 16 is 4. What's the square root of x to the 6th, Cameron? Nope. That would be the cubed root. If I'm taking the square root of an exponent and divide it by 2. X to the 3rd, yep. So x to the 3rd comes out as well. So I've handled that and I've handled that. And then I don't know the square root of 2 and I don't know the square root of x, so those two just sort of stay underneath the radical. Okay? If I jump to 6, root 27 breaks down into root 9, root 3. Is x squared a perfect square? Yes, so I don't need to break it down. Is y to the 4th a perfect square? Yes, because it's an even exponent, so I don't need to break that down. And then I'm just going to go through and circle the things I can take the square root of. What's the square root of 9? What's the square root of x squared? X. What's the square root of y to the fourth? Y squared, right? And so the only thing kind of trapped under a radical is the radical 3. And then I just have to clean up what's up in front. 5 times 3 will give me 15. X cubed times an x is x to the fourth. So that takes care of the 5 times 3. That takes care of the x cubed times x. And then the y squared is just kind of out there times root 3. Spirals are coming out, followed by your homework. I'm going to have to modify your homework because you didn't get through. So when I hand you the worksheet, I will let you know what ones you're doing. So you're going to bear with me. Or how about this? I'll send